Here we are going to perform an experiment based on the concept of a thermocouple. To perform this experiment, these are the materials that we require. Firstly, two dissimilar metals are required. In this case, we are using copper and stainless steel wires. Secondly, we are going to use a cup of hot and cold water to act as the hot and cold junction. Lastly, we will require a digital multimeter to record the voltage across the two junctions. After preparing all the materials required, we are ready to proceed to the experiment. Firstly, to create a closed current, we are required to solder the wire together. However, since the soldering is not available to our group, we have decided to twist both ends of the wire to one another to imitate the closed current. Here, one of our group members displays the process of twisting the wires together.
To prevent unintended errors from the twist, our group members has used the wire cutter to trim the ends of the wires to ensure that the point of contact from the temperature junction are closed.
Here, we connect the black wire to the steel wire, while we connect the red wire onto the copper wire. The red wire represents the positive terminal of the voltmeter, while the black wire represents the negative terminal of the voltmeter. Now with the wires connected, put one end of the circuit into the hot junction and the other end into the cold junction. Note that we have connected the voltmeter parallel to the circuit. With the ends in contact with the two temperature junctions, the thermocouple setup is now complete. Now we are ready for the experiment. Notice that the digital multimeter displays voltage. This indicates that the circuit had been successfully put together to form a thermocouple. However, you may notice that the digital multimeter is displaying a variation of voltages. Upon inspection, we realize that the change in voltage is due to the temperature of each junction. Since the temperature junctions are not constant due to the exposure to the ambient temperature, electron flows through the circuit would vary. Now, moving to the explanation of a thermocouple and why the voltmeter indicated electron flow. A thermocouple is a device used extensively for measuring temperature. A thermocouple is comprised of at least two metals joined together to form two junctions. One is connected to the body whose temperature is to be measured. This is the hot or measuring junction. The other junction is connected to a body of known temperature. This is the cold or reference junction. Therefore, the thermocouple measures the unknown temperature of the body with reference to the known temperature of the other body. Now, we are going to do an experiment to prove that the difference in temperature will affect the electron flow, or rather if there is any electron flow at all. We are going to connect the black wire to the stainless steel wire as shown, and we are going to connect the red wire to the copper wire. Note that both the junctions of water have the same temperature. The setup of the experiment has been kept at a constant as compared to our previous experiment. However, the variable this time around has been the temperature of water. As you can see, the voltage across the circuit is very low, and this would either mean that the temperature junction across the wires have a very small difference, or that the wires do not have any electron flow. Thus, the voltage across the multimeter could be deemed invalid. As you can see from above, the voltage across the multimeter would eventually become negative, proving that the value across the multimeter is indeed invalid, and thus you can conclude from this experiment that if the temperature across the two junctions are not different, there would be no electron flow. Likewise, if the two junctions vary in temperature, we have now generated electricity through heat. Now, with the results of the experiment, we are ready to move on to our conclusion. To conclude, let me run you through some stuff we have learned from this experiment. The minimum requirements for a thermocouple are the two different temperature junctions, two dissimilar metals, and a voltmeter for measurement. The change in temperature across any heat junction would mean that the intensity of electron flow through the circuit would vary. We were unable to find the conductivity of the wires through the use of a thermocouple, but we now know that for a proper implementation of a thermocouple on an aircraft to measure the ambient temperature, we would need to know the conductivity of each of the wires used. We found that the findings from our experiment matched the theory of a thermocouple. So we can say that the experiment was a success. With that, we thank you for watching the video and have a nice day.